Okay, I promised to talk a little bit about what we don't know. This is always one of the most difficult things you can talk about in historical study. And I'm going to continue the theme of previous episodes by looking at a die study of another Roman Republican moneyer. This time, Fabius Pictor. Pictor was the subject of a study by Crawford in the 1960s, and Crawford placed him at the very beginning of the period of Roman Republican coin production in which complex control mark systems were used between 126 and 63 BC. Okay, I know there are people who listen to my talks who know a lot about Republican coinage, and I don't. I have no idea what the current state of thinking on the chronology of Republican coinage is. I don't even know if much work's been done since Hirsch and Crawford were doing this, and if you do, then by all means leave a comment. So for the moment, let's just accept Crawford's statement that the possible chronological implications of this fact, by which he means the complexity of Pictor's coinage, are the most interesting, since at least some of the denarius issues before Pictor seem not to have had this structure, but to have been produced on one anvil with a simple succession of obverse and reverse. We are going to see some counter-evidence, but here Crawford is positioning Pictor as the moment of transition from a relatively simple mint, typical of the ancient world, to the elaborate, highly professional and weirdly idiosyncratic mint that Rome becomes, the mint of Bercio and Cropusius and the Empire. And you might expect to see that change in the coinage itself. You see, under Pictor, two types of coins are made. We have coins that are marked with letters on the obverse below the chin of the goddess Roma and on the reverse in the right field above the chair. But we also have coins which are not marked at all. When Crawford published, he found a complex interaction between the coins with letter marks, as illustrated by this spider diagram. It's the 1960s, so we can't expect better than a spider diagram, but not between those without a mark. The unmarked dies in Crawford's study consisted only of singletons and an isolated obverses. An obvious thought. When Pictor took over the mint, it was still making coins in the way it had in the past, sporadically in modest numbers with a single workstation, replacing a die only when it broke. But at some point in his tenure, that changed. The mint started using multiple dies, presumably in order to allow more intense production, and with that shift in practice came the control marks. Again, I know nothing about Republican coinage. So, let's all just pretend for the moment that this is a plausible hypothesis. And if it's not, then, and somebody has shown in the last 50 years that this is definitely wrong, then by all means, leave a reference in the comments. The problem is all the missing data. Our picture of the mint is incomplete. How do we know that the missing data doesn't show that unmarked coins were a much more complex production? In other words, our data shows that the letter coins were a complex production, but it does not show that the unmarked coins weren't. This is actually such a general problem in the study of material culture that archaeologists have coined a rule for it. Absence of evidence is not evidence of absence. Let us begin with the quality of our sample, usually measured as the mean number of known examples per die, the N/D, or index number. I've actually been thinking about this for a while, and the index number is not actually very good for comparing between different coin traditions. For Rome, you often have a very similar number of obverses and reverses, but for example, in the Hellenistic world, there's usually a massive proliferation of reverses, far more than there are obverses. N/D, if you use the obverse, makes the sample sound much more complete than it really is. Increasingly, I think it's useful to average the results for obverses and reverses. So that would be 2n/do plus dr. For the largest group, Crawford knew of 104 examples for 12 obverses and 15 reverses, which gives us a figure of 7.7. That's a pretty good sample. By contrast, the small chain had 10 examples, so that works out at 4. Unfortunately, I cannot give you a number for the unmarked dies, and to explain why I need to explain the difference between sampling error and systemic error. Sampling error is the thing statisticians talk about. Imagine the surviving coins are just randomly selected from the ancient circulation. They aren't, but imagine they are. There will still be coins that are overrepresented and coins which are underrepresented. That is sampling error, and it is probably why the dies in the chain are more poorly represented than those in the complex group. But usually in historical study the problem is that the surviving, or in this case the published coins, are not randomly selected. Instead, there is a deliberate selection for certain types over others. This is a systemic error. In the case of Crawford did not care very much about the unmarked dies, so he published only one example of each. But likely he was already working from a systemically distorted sample, because collectors and museums, the latter are Crawford's main source, cared more about the lettered dies than the unmarked. And there is no way to adjust for that. We cannot draw an inference from Crawford's omissions. Absence of evidence is not evidence of absence. This is a general problem. There are ways to detect systemic errors, but very few ways to compensate for them. And because of the nature of historical study, they are usually much more of a problem than sampling error, which is why I make quite limited use of statistical tools in my work. They tend to encourage false confidence rather than actually solve problems. Anyway, back to the issue at hand. The unmarked dies show a less complex interconnection than the lettered dies, and we want to know if that is because we have a worse sample. So the first thing I needed was more data. And I went and collected a bunch for myself. I found more die combinations, which is not a surprise, and a bunch of additional unmarked dies. And that did make the unmarked dies more complex. For example, this new combination promotes some of the unmarked dies from being singletons to being a simple chain. Have I explained the typology of inter-die complexity? I feel if I haven't, I should have done. Any connected group of dies is a linkage. The simplest linkage consists simply of a single die combination, a singleton. A little more complex are isolated obverses and reverses, which have die links. And then of course we have the die groups, where there are die links between both obverses and reverses. The simplest of these are chains, but more complex arrangements are possible, both planar and non-planar. And when authors like Crawford talk about a die box, it is these they are referring to. With the additional data, I now have 8 unmarked obverse dies and 9 reverses. I've updated Crawford's data here just for the unmarked, and that consists 5 singletons, an isolated obverse, and a simple chain. Since none of my unmarked coins overlap with Crawford's, and my collection of letters are roughly comparable with his, we can probably use my data as a rough guide for the sample of unmarked coins. I had collected 16 dies and 21 coins, which gives a result of 2.6, significantly worse than for any of the lettered groups. So, is the difference between the unmarked and lettered dies just about the sample? Is the absence of complexity just an absence of evidence? It might well be, but in the process of doing this, I also found something that Crawford had missed, which upended a lot of assumptions. This is an example of the second unmarked die, and this is an example of the C obverse. And the interesting thing here is the very distinctive design on the wing, which is normally drawn as 3 lines, but here is drawn as 2 clumps. These are the same die. I can only assume that Crawford was so uninterested in the unmarked dies that he never looked at them properly. Anyway, this kind of thing happens a lot. It's a point I always try to impress on students. I have never looked at a die study and not found something unexpected and interesting. Obviously, I mean interesting in a dull, nerdy way, but still, at least, that's odd. This reflects in part how underutilized these tools are, but it also, I think, reflects how much you see when you look at something very, very closely. This is a recut. I had been kind of expecting to see recuts in the Republican coinage. The elaborate control mark systems seem to constrain the use of dies, so they are removed from use long before they are worn out, and it seemed natural that you could simply recut the mark rather than throw the whole die away. But I've yet to find one in any of the elaborate series. However, here clearly happened, and this was not the only one. An unmarked die was recut to make the B die, another to make the D, and one to make the F, and I found 3 reverses, B, C and E, recut from earlier unmarked dies. And here I think we can be quite confident that there is missing data. If I look at the A dies available to me, they show pronounced signs of die wear. You can see here pit flaws and cracks in front of the face, and around the coin are fine radiating marks. The radiating marks are a very common feature of mechanical stress on the die face. Every A die I have seen looks like this. The A die in Crawford's article, despite the poor quality of the pictures, you can see has the pit flaw. So I imagine there must have been an unmarked die, and no example of which survives, which was recut to make the A die. The picture's a little more ambiguous for the E die because while there are obvious signs of wear, I've seen examples that look like they don't have very much wear. But G is particularly interesting. There are noticeable cracks in the die face, but there also appears to be a clear progression. Look at the die on the right, where they are much less pronounced. And that seems to be the general pattern after F. I can usually find a die from a reasonable photo that shows no or very little trace of die wear, which implies, doesn't prove, because a die can actually get quite a bit of use without showing much wear, that the dies after F are not generally recut from earlier dies. It seems that 6 unmarked dies were available in the mint and were recut to be used the first 6 lettered dies, and in all probability the same thing happened with the reverses. 6 unmarked reverses were recut as lettered dies, which is not what Crawford thought was happening, and it implies the mint had a lot of dies available that they could have used in combination with each other, but they didn't. Because if the mint was combining 6 obverses and reverses, then in theory it would look like this. But the chart we are dealing with actually looks like this. Okay, so these episodes are a bit unusual. Usually when I record something, I have a specific point to make and the episode is built entirely around that point. Nothing here is live from my desk. Everything is scripted. Even this bit where I'm telling you it's scripted is scripted. But in the case of these episodes, I work from contemporaneous notes of what I was actually doing when I was working on this. So though I began intending to give a talk about die charts and inter-die analysis, and I actually wanted to get to a specific point about how to use histograms, which I will get to, I genuinely had a wow, how did Crawford miss this? And spent quite a bit of time then doing an intro-die analysis and a whole bunch of follow-on stuff from that, which kind of led into the restructuring of what I was doing that you've literally just partly gone through, and which I will be carrying on talking about in a second. And that's normal, me switching between meta and intra-die analysis on a regular basis. If you've never listened to me talk about die studies, once you have a corpus, a body of data, you have 3 ways of engaging with it. The first is meta-die analysis at a statistical level. The second is inter-die analysis, the pattern of connections. The third is intra-die analysis, where you narrow right in and look at only examples of a single die. And while that description is true, and it's a useful way to think about it, and it's how I teach it when I lecture, it's not how I actually do this stuff. My actual process is all over the place. It's much more holistic. I move constantly back and forth between different types of tools because of precisely those, that looks odd kind of moments. So while I absolutely had an endpoint for this video, that trick with histograms I've just mentioned, I did get sidetracked into doing this. And I don't know if presenting it in the way in which I did it makes it more interesting to you or just much more confusing. But what I can tell you is that it makes it much more representative of how actual research is done. Okay, where are we up to? We now know, because of the recutting, that there was a moment when the Mint started using lettered dies, and we know that at that moment in time the Mint had 6 obverse dies and probably 6 reverse dies available, and that it had these dies, which were not fresh, re-engraved with letters. And we can infer that there was a period before this when unmarked dies were used alone, and after this when fresh dies were cut, because we have too many unmarked dies for all of them to be recut, and we have lettered dies that appear to be fresh. And that is kind of interesting because it makes clear the Mint did not have a single plan from the beginning. We also know that the Mint ran out of letters. There is a single surviving die with an upside down A, which was obviously cut to deal with what happened when you got to the end of the alphabet. But, and there are a bunch of things we could focus on, but we'll focus on this because of the absence of evidence theme. None of the die groups are complex enough to warrant the assumption that the Mint employed 6 workstations. In other words, it did not need 6 dies to exist simultaneously. Is that a function of the Mint's production being less complex than it could have been? Or is it simply because we are missing the data that illustrates the complexity? To answer this, I began by working through my own and Crawford's data to get some counts of material. For this, I counted the unmarked and lettered cuts of the same dies separately, and I stuck this data into a spreadsheet. I found 25 examples of unmarked coins, from 8 obverses and 9 reverses, and 173 examples of 14 and 21 dies for the letters, which confirms earlier thoughts with regard to the N over D. Our sample is much better for letters than unmarked. Since we have a formula for it, I can calculate the number of dies that originally existed. As we can see, this suggests probably 8 or 9 unmarked dies and maybe 3 or 4 lettered dies are missing, which matches up well with our expectations from other evidence, but unfortunately tells us nothing about complexity because we don't have a formula for die combinations. But we do have a graphical trick. Let me show you how it works with the lettered reverses. This is a histogram and shows the number of dies known from a certain number of examples. These sorts of charts are very useful. They help you check that there's nothing odd going on with the data because incongruities indicate that there's some systemic issue. They should, as this does, look like a falling curve, leading sharply off from single examples into a long tail. As the histogram gets very flat, that is an indication that all of the dies are known. Now our next step is to project a line of best fit through it, a curve that follows the data as closely as possible, and try to imagine what the bar would look like if there was one for 0 examples. Because that's what our formulas are trying to do, estimate the number of dies we have 0 examples of. And this isn't bad, it suggests maybe 3 missing dies, which is almost exactly what the formula predicted. Obviously, it is imprecise and subjective, and not a substitute for a formula that has some 30 years of research tested along 2 independent strands of evidence. But remember, we don't have a formula for the die combinations, or a collected body of data that would let us test one. Here I plot the number of die combinations. This is for the entire sample, including both unmarked and lettered dies. Note that we do not find combinations of unmarked and lettered dies, only ones in which both dies have letters or both don't. You can see immediately that there's a lot more missing data for the combinations than there is for the dies. How much? It's hard to say. 10 to 20, maybe more die combinations. But there isn't enough missing data. To explain, I think we need to revisit the academic argument Crawford was engaging with over half a century ago. Before his study, other people had looked at the letters and realised that the obverse letter generally did not match the reverse one, and referring to Barfelt, Crawford writes, he eventually decided without much enthusiasm that every letter on the obverse of the Republican denarii is combined with every letter on the reverse. Crawford was able to show through his SNI study that this was not the case. There was pattern to the combinations. He did this using a chart because it's 50 years ago, checkerboard and workstation diagrams weren't really a thing yet. And he wrote If the combination of obverse and reverse letters are plotted diagrammatically, it is at once apparent that the workshop producing the issue used more than one anvil at a time, and that any current obverse die could be paired with any current reverse die taken from a die box. Let us think about these two explanations. The first assumes approximately 300 die combinations, every obverse letter with every reverse letter. What about Crawford's? Well, he did not know how many obverses or reverses the Mint had, just that they had more than one of each. We do. We know that at a particular moment they had 6 of each. The theoretical relations between the total number of obverses, reverses, and the number of each available at any one time can be expressed by a formula. And it gives a pretty big number, maybe 200-ish, depending on a bunch of assumptions. The die group does not have anything like that number of die combinations. It has just 39. There are only 47 die combinations known, and going back to our plot of them, there is no way we are missing a few hundred combinations. Even if every missing die combination were jammed into this chart, we are not getting anywhere near that level of complexity. To illustrate why, let's look at the data a different way. This is a slightly more complicated plot of 3 pieces of information. Take, for example, the reverse marked A. There are 19 examples of this die known to me. It is known from 2 different die combinations, obverse A with reverse A and obverse B with reverse A. So we plot it here on a graph. But there might be other reverses which are known from exactly 19 examples and in exactly 2 different die combinations. So we use the size of the circle we plot to indicate how many. And the resulting chart looks like this. Obviously, down at the bottom left, when we only have one example of the die, it can only be known from one die combination. As the number of examples increases, so it becomes increasingly likely that we would discover other combinations. But that effect levels out as you move to the right, because obviously you cannot discover more combinations than were actually made, and there were probably very real physical limits on how many times you could pair a die before it broke. The interesting feature of this chart is that it levels out well short of 6 combinations. The same pattern is apparent with the obverses, and this reflects what our die chart is showing us. This production just isn't that complicated or interconnected. Sure, if the data was more complete, it would probably be a non-planar chart. But Crawford was wrong. The Mint did not simply pair dies that were available to it at random. And while there are a lot of potential explanations, if you watched the last video, then I think this one probably occurred to you. That there is a difference between the dies that were available, in the sense that they existed, and the dies that were released to the workers for actual use. And the latter was always substantially less than the former. The charts themselves offer some clue to this. There are various ways to arrange the data we have, but all of them suggest something interesting, which is that the sequence of letters holds up much better at the beginning than at the end. Why? Well, probably because at the beginning the letters were being released to the workers in sequence, but with time that increasingly wasn't the case. Why withhold some of the dies? Probably simple practical administrative control. If only 3 workstations were operating, why release 6 dies to the workmen? Dies are central to production. You want to control them, and releasing more than is needed would serve little purpose. Could I say more about the coinage of Fabi Pictor? Oh yes, I've barely scratched the surface here. One of the things that could be done with the present data is to really delve into the intra-die analysis to try and track what order coins were struck in. That would provide an invaluable complement to what I've already discussed. Though to be fair, I did really just pull it out to illustrate the problem that the real production is always potentially more complex than our surviving sample, and to show you that trick with the histograms. So, thank you for listening.